Okay. The problem says, solve the following system of equations algebraically. Whenever you see algebraically, that really just means by hand, okay? By hand. So if it says solve these by graphing to find the intersection, that's your calculator. Or if it says solve these by using a graphing tool, that's your calculator again. But when it says algebraically, we need to solve this by hand. Now, there are several ways to actually solve this. Sure. Andrew, can you hit the other light, please? And Julia, can you just turn one of the blinds a little bit then? Just rotate it so they get some light. I said Juliet, but Vanessa got it.
You said Julia.
Oh, sorry. You guys sit right there. Next to each other. Okay. Now, for this kind of a problem, it can be very difficult if you don't follow just certain steps. The easiest thing to do, whenever you have something where this is called higher order because it's not linear anymore. When you have something that is higher order, use substitution. That's going to be the goal here. I'm telling you now. Remember how we were using elimination for linear systems with 3 by 3? Now we're looking at substitution. So this is higher order. The order of an equation just means the exponent. So by higher order, it's higher order because it's x squared here. That's the only reason this is higher order. If this x squared term was not here, so make believe this was not here at all. Now it's just a linear equation. It's 2 by 2. You can solve this with a matrix. You can use elimination. You could use substitution. But you know what? That x squared term is there. So I can no longer use elimination. Elimination worked because we were able to line up the equations and add them together. And they would cancel stuff out. If you try that for this one, it's not going to work the same way. Whenever you have something that is squared, you really want to use substitution method. So that's our first thing we want to write down. For higher order, use substitution, please. Okay, we are not using elimination anymore here. Juliet.
For this one, why don't you just plug in, what says that y equals to x squared plus 2x. You just plug that in y.
Absolutely. Absolutely. I would do the same thing. And I was going to ask, because there's several options here. You could do what Juliet just said, which is this. This whole thing is the definition of y. It says y equals. So you could take that and replace this y with that entire box. So if I plug in, and let's say we'll call this 2, and I'll call that 1. If I write my command down as plug 2 into 1, I will end up getting x plus that whole thing equals 7. Again, I'm taking the box and plugging it into that blue circle up top. And I'll end up with x squared plus 2x minus 5. That is one way to do it. And that's the way that's probably the easiest to do it. Does anyone see another way to do it? Because there are many other ways to do this problem.
You set the first one equal to y, and then plug it into...
Set the first one equal to y, and then set them equal to each other. So here, solve number 1. This is another way to do it. If you solve the first one for y, you'll get y equals 7 minus x. Everybody see that?
Right.
Again, move this x over by subtracting x. Now, this is what y equals, and this is also what y equals. You can set this equal to this. Again, if the definition of y is given in equation 2 here, and we've also given another definition of y in equation 1, we could set those red circles equal to one another. Ashley?
Can you subtract y and then it will be x equals
7 minus y, and then what? Absolutely. Now, that was the third method, and this is the one time I would not do that, and let me explain why, but I understand what you're saying. I absolutely agree it's another method. If you solve for x here, you get x equals 7 minus y, which is similar to y equals 7 minus x. But if you were to substitute, now you've got to substitute this in here and here in 2 spots. And then you know what? Then you have to square this entire binomial, which means you'd have to FOIL. So it's a lot more work. There will come a time where you cannot avoid that, and you have to do it. But for now, if we start with the first one or the second one, it makes it a little bit easier because we don't have to worry about foiling anymore. Okay? So let's continue with our first method. Again, there are many techniques and ways to do these problems. There's not only one solution here. Again, I'm sorry, there is one solution. There's not only one means to that solution. You can do this 3 different ways we've already seen. And some of these problems you can do it 5 different ways, depending on the problem itself. So for now, let's continue this process. Here, just collect terms. The only like terms are x and 2x. I want to move this 7 over here also. So when I do that, I'm going to still have an x squared. How many x's am I going to have now?
3x.
And then what's the end term going to be?
Minus 12.
Minus 12. Okay, be careful, guys. Minus 12. Again, how do you get rid of the 7? Subtract 7. Negative 5 minus 7 is negative 12. And now what should I do to solve this?
Foil.
Good. Unfoil, you mean, but I got you. Factor. Okay, so either factor, or you know what? You can go right to the quadratic formula, because a lot of these problems are going to take the quadratic formula to solve. This one might not. Are there numbers that multiply to give us 12 and add up to negative 12 and add up to 3? 6 and 2 is a 4, right? I could try 6 and 2. Remember how we do this? We list our sum and our factors. If I try 6 and negative 2, or negative 6 and 2, that doesn't work. 4 and negative 3 doesn't work. Negative 4 and 3, that does not add up to 3 either. 12 and 1 won't work either. So can I factor this one? No, so what do I have to go to automatically? Quadratic formula. So either run your program in your calculator, type in A, type in B, type in C, get your answer. Again, we wrote that program for a reason. Use it, please. Or just do it by hand using the quadratic formula. If we solve this one using the quadratic, check your answers. I'm going to write them up here.
Next.
We should get 2 answers because it's the quadratic formula which says x equals negative b plus or minus. Remember, 2 answers here. You only get 1 answer if it's a repeated root there. Now, again, that's what I did using the quadratic formula. I'm not going to show those steps, guys. That's what we did already in concept 22, in concept 23, in concept 24. Okay, we've done that several times now. I'm not going to stop and go over that again. So the quadratic formula gives me 2 solutions. Now, what did the original problem say, though? What did the original problem say? Solve the following system. So we got x. When you solve a system, you have to get a coordinate, right?
Y.
So I need the y value. Very good, Juliet. But how many x's do I have?
2.
So I need to plug each of them in separately and get 2 different y's also. So what you need to do next is take the first x, and now, which one would you guys plug it in? The first one or the second one?
First one.
First one is a lot easier. I don't have to worry about squaring anything and multiplying stuff. So plug this into the first equation right up here. So take that value, plug it into the first equation, get an answer. Then do it again with the second value. Plug that in the first equation, get an answer. So you need to do this twice now. Again, plug x back into the first equation, get y. Plug x back into the first equation, get y. Do it twice, please. And I'm going to write it in the same order. So make sure your order is consistent. So if you're plugging in here, put your answer here. Plugging in here, put your answer here. Okay, make them respective of one another. What do we get, Anthony? 12.27.
Yeah.
And then your 73 is over here. 4.73 is over here. You did the minus plus thing, right? Yep. I got you. Now, again, how did I get these numbers just now for y? I took my value of x, and I took my other value of x, and I plugged it back into the first one. I did it separately, though. Again, you're not solving simultaneously once you're done here. You got the x values, you're done solving simultaneously. Now, these are paired up. They go together because how did you get the 12.27? You plugged in the negative 5.27. How did you get the 4.73? You plugged in 2.27. Very good. So again, your final answer needs to be listed as your coordinates. Negative 5.27, 12.27. That's one of your answers. Again, we're finding the solution. That's one answer. And the other one is your other answer, 2.27 and 4.73. So at the end of the whole problem, this and the final black box down here is your final answer. Again, you got 2 different answers here. 2 different answers. There's a good chance you got 2 different answers here because it was a parabola and a line. What did we call that graphically? Does anybody remember? When you have a parabola and a line and they intersect to give you 2 answers, what was that called?
Secant.
What is it?
Secant.
Secant. Again, we are looking at an example here, and on the next page I graphed it for us, of this, where we have, whoops, sorry, of this, where we have a parabola and a line. And look at the coordinates, guys. Aren't those the exact values we just got? Here's the second one. Here was the first one right here. Okay, so again, what are we doing here? We're finding intersections, but we're doing it by hand now. So if you did this on the calculator, you should always check it. Please check it. Don't just assume that you're right when you do it by hand. So even if it says solve this higher order system by hand, do it, but then at the end, you know what? Go back, plug this into Y1, right here, plug that into Y1, plug this into Y2, find the intersection on your calculator, and check that these two answers at the bottom are correct. Just like we did with a matrix. Even if you solve a 3 by 3 by hand, with concept 28, part 1, you should still check with a matrix. Because it takes, what, maybe 20 seconds to input those numbers? It's worth it to check. And it's much faster to check with a matrix than it is to plug them in by hand. Okay? All right, that's our first one. Let's go to a second one now. Let's take a look at this one now. Same idea, but instead of having a linear system and a quadratic, now we have two quadratics. Say again? Well, you have two of them. So if you use the quadratic on them individually, you're finding the roots. That's what we're going to try and do now. I'll give you a second to write it down. All right, before we even get started, let's go to logic and think logically here. What does f of x really mean? And what does g of x really mean? So aren't they both solved for y already?
Yeah.
So what can I do to them? Set them equal. Very good. Again, think of this as y. Think of this as y. If they're both y's, then these must be equivalent. It's like saying the definition of this word is something. The definition of this word is the same thing. Aren't they synonyms? Isn't that what you call them? So these are synonyms of each other in a sense. They're the same thing. Set them equal. Now, please, please, do not start with the quadratic formula just yet. What do you need to do before that? What does combine mean or simplify? Get everything on one side. Very good. Again, quadratics, you need a 0 on one side. So move everything over. Now, there is an easy way to do this, and there is a difficult way to do this. If you're going to try and factor eventually, you want to have a positive x squared, really. So you probably want to move this over here. So I would move all three of these over this way. Understand what I'm saying? So that you get a positive x squared, because you're going to add 2x squared now. So remember, when you move something over, just switch the signs. So if I want to move all these over, I am simply saying, okay, I need to add 2x squared, add 2x squared. I need to subtract 4x, subtract 4x. I need to subtract 2, subtract 2. On this side, these all cancel. That's where a 0 comes from. You're moving them all over. On this side, we add the opposites of those signs. Now, in this kind of a problem, you could try AC method, but you know what, guys? Go right to the quadratic formula or quadratic program. Okay, AC method is great when we need to factor and get factors. But the factors really don't matter here. It's the roots of this equation that matter. I want to know what is the value of x itself. Okay, so again, please, you could use AC method and try it out and see if it works, but it's not really worth your time.
1.4.
Good, and? Very good. Now, this is one of those problems where AC method would have worked. I'm telling you now. AC method would have worked on this problem. AC would have been negative 35, and B is negative 2. The numbers that would have worked for that would have been 7 and 5. Okay? Again, AC method would work, but you don't need it. Use your quadratic formula or program. Are we done yet?
No, that's plugging back in.
Very good, because it says find the intersections. So take a look, guys. The original functions here, find the intersections, or where do they intersect. So I need x comma y, x comma y. Well, I've got two different answers for x. Good. Into which equation, Juliet?
Either one.
Very good. Does it matter this time?
No.
Take a look. It makes no difference which one you plug it into. It really doesn't. Okay? It really makes no difference at all. So go ahead and plug them in either one. You said first one? That's fine. It doesn't matter. I would probably choose the first one also. It really doesn't make a difference, though. It's just random choice. When you do plug them in, And I'm putting them in the correct order, guys. Again, line them up, please. Again, when you plug in your two values of x, it does not matter which equation you plug into, but you have to check that you get the same y's that way. Again, you do not need to actually plug this in and type into your calculator. You could put your function into y1 and then just use a table function. So again, you could put f of x into y1. You could put this into y1 right here, and then in your table just type in a -1 as your input and see what you get out. You'll get -4. Type in a 1.4, you'll get 3.68. Again, the table function is useful on your graphic calculator to do some stuff quick. It does direct evaluation very fast. You don't need to go there and type it in every time. Hey, let's see what this one looks like now. In case we're wondering, see what it looks like. We had two parabolas originally, so there's a good chance it's going to look like that. We have two intersections. One was opening down, one was opening up. Remember, there was a -2x squared in front of one of them. The -2 meant it was opening downward. The +3 for the other one meant it was opening upward. And if we have to the fourth, well, the next one we're going to look at, okay, it's still squared actually. If you have, cube looks like this. We haven't gotten to those graphs yet. That's why I'm not doing too much with those as the next topic really. That's a cubic graph, either that way or this way generally. A quartic, or the fourth, looks like this, or looks like this. Okay? Or it could actually look something like this. Or it could look like, as long as it has like another curl to it. It doesn't matter which one you want. You know what I mean? Either way. Okay. Let's take a look at this one now. This one's a little bit more complicated. We have a total of 4 examples, so we have one more after this. No, I'm showing you the graphs. I'm verifying. Now, if you want to check these answers are correct, you can type in those two functions and do y equals and then graph them, and that's what you got. I'm just showing the verification. Again, guys, you don't have to graph. It's a good thing to check, though. I would personally do it every time. Even if you eyeball it, okay? Take a look at your graph afterwards, see if your answers make sense, if they're logical. A little bit more complicated here, and I'm assuming most of you can see why already. Who can explain to us why this is more complicated? Daniel. Good. You got x squared here, you got a y squared here. So I can't solve for x or y in the first equation, really. Again, take a look. I cannot solve for y because it's in 2 spots. I can't solve for x because it's in 2 spots. But in this equation, I could solve for one of them. Which one might you want to solve for? Does it matter, Isela? Very good. It does not matter. Well, you said it doesn't matter. It makes no difference, guys. Solve for y or solve for x, either one. Personally, since I could just add y, I would solve for x here. Right? That works, and then just plug it in. But how many spots do I have to plug it in now? 2 spots. I got to take this and plug it in this spot, and I got to plug it in that spot right there. So here's the problem now. I'm going to have to square, and I have a binomial. So I'm going to have to FOIL up here. And let me show you that step. Notice what I'm doing right now. I left blanks to show that that's where I'm replacing. Okay, again, I'm replacing the 2 plus y in for the x there. So there's going to be a 2 plus y right here. And there's going to be a 2 plus y over here. Now, the 1 over here is easy. You're just going to distribute the 4. But over here, you have to remember, you need to FOIL first and then distribute the 2. Again, please write this down if you didn't write it down or if you don't know this right off the top of your head. You cannot distribute this 2 in here. Remember, PEMDAS. First, you have to do parentheses. Well, there's nothing you can do here. You can't combine 2 and y. Then comes exponent. Then comes multiplication. So this 2 on the outside has to wait to get distributed until we square, until we FOIL. Juliet.
Why is 2 plus y if you Or you do it moving the y over?
All I did was move the y over. You could do y plus 2 or 2 plus y. Either one.
It's gonna be plus now multiplication, right?
It's going to be what?
It's gonna be plus now multiplier, right?
Yes, because again, this was minus y, and how do I get rid of a subtraction of y? I add it to the other side. Okay? So here, when I FOIL this, what do I get here, guys?
4
2
plus
times
4y plus y squared.
Again, what am I doing right here? Okay? That's what's going on there. You're doing 2 for this entire thing right here. It's 2 plus y, and the 2 remains on the outside. Minus 3y squared. Now, please distribute this 4. You don't have to wait. This one, there's no square, so you can distribute right away. At this point in time, now distribute the 2 in the front to each term, and then the last step is to collect all of your terms. And notice, you're still left with a quadratic here. You're still left with a quadratic. Now, over here, you can already start combining like terms. Like here, you can combine these in the middle of the step. You can move the 7 over and subtract it from 8 and just put a 1 there also. Do you guys see what I'm saying? Yeah. Even though I'm distributing the 2 on the left side, I can still collect terms over here if I want to. Okay? So this is still going to be minus 3y squared. Instead of plus 8, I need to get rid of the 7. So if I subtract 7 from 8, I get 1. Again, if I subtract 7, I'm going to get a 1. Now clearly I'm going to have to add that 1 and that 8 together, but that's not a big deal. I'm just collecting like terms here, and then I'll collect more like terms later. You do not have to do it all at one time. So at this point, we have 4y minus 3y, which is just 1y. So again, you can collect terms in the middle, or combine like terms, thank you, Brendan, in the middle of the problem. It does not matter. You don't have to wait till the end. Now at this point, you can collect all of your like terms. So here we've got 2y squared minus 3y squared. Thank you. Thank you, guys. For here, we have 2y squared minus 3y squared. What do I get for that? Negative y squared. Again, it's 2 minus 3, which is negative 1. Here, I've got an 8 as a whole number, then I got a 1. What does that become? Then I've got 8y here and a 1y here.
9y.
Again, this 8 combined with this 1 over here, this 8y combined with that 1y right there. Now, you cannot factor this. It does not work. But if you were able to factor it, you would not want a negative in front, right? How do I get rid of that negative? What is it? Switch all the signs. Divide everything by negative 1. Remember, if you ever have an equation, at any point in time, you could switch all the signs. You're allowed to do that. If you divide this side by negative 1, it just ends up switching the signs. Well, divide this side by negative 1. It's still 0. So you could actually write this as this. And I would recommend doing this. Even though you can't solve this by hand this time, you have to actually use your quadratic formula to do it. But still, if I were to try to factor, I would want a factor to look like that. I would not want it to look the other way. I would want it to look just like that. Now remembering, we are solving for the y-coordinate here. It's still using the quadratic formula, though. So solving with the quadratic formula, or the quadratic program, a is 1, b is negative 9, c is negative 9 as well.
Isn't it 9.9 and negative 0.9?
Absolutely right. It is 9.91 and negative 0.91. Okay, and Juliet, are you using your program? Is that what you're doing every time?
Yeah.
Awesome. Good job. Notice how fast she is with the response? Again, we wrote the program for a reason, guys. Use it. Now, next one. I want to have what x is. Again, take a look, people. We did all this work to get y. Now, I want to know what x is. Which one should I plug it into? The second one. It does matter this time, guys. Look at the second one. Why would you ever plug it in that first one, right? If you plug in the y in here and in here, you're still going to have x squared. You have to use another quadratic. Please don't. Plug it into the second equation only. Plugging into the second equation. Anybody want to give me those ones? Okay, that's what you should get. Please check your answers. Again, I plugged in this y and this y into this spot right here and solve for x. Again, you're plugging into the second equation to solve for x. Once you get the x values, then list your coordinates, please. So pair them up. 11.91, comma 9.91, and 1.09, comma negative 0.91. Now, this example is one where we have a hyperbola, and I want to show you what that looks like, because this does look a little bit funky. You cannot graph this. Have you guys noticed, by the way? Look at the first equation. Look at the first equation up here, if we can actually get there. Looking at the first equation, there is no way you can plot that in your graphing calculator right now. There is an app that I can show you at some point where you can download to your graphing calculator. They have applications on there that allow you to do what are called conic sections. Conic sections are circles, ellipses, parabolas, and hyperbolas. Parabolas you can always graph. You guys know how to do that. There is a way to graph this, but you need to download a certain application onto your TI-83 or 84. It works on both. And I can show you that. But since we're doing it by hand right now, I just went through and did it. Now, if you type this into GeoGebra just like that, it will graph in GeoGebra. Okay? And what it looks like is the following. If we were to graph this one, that's what it looks like. We have the line, which is the dashed one. That was the second equation. Remember that first equation? That's the hyperbola right there. Okay, and notice, look at our answers. 1.09, negative 9.91, 1191, 991. Exactly what we got a second ago. Again, you can't really check this on your calculator. That's why this one is a little bit tougher too. Okay, last one for the day. What is the location of the intersection of the hyperbola and the line to the right? Okay, what is the location? Now, you could say, well, it's around, 1, 5, and this one is around negative 3, negative 2, but it's not exact at all. Okay, it's clearly not crossing on a hash mark. Not that you could even see the hash marks, I don't think, right now. Okay, but it's not crossing on any of the hash marks. But we have two equations. Let's list them. So I got xy equals 4, and I've got 2x minus y equals negative 4. From the graph. It's on the graph. The lines are labeled. You can't see it. Sorry, the lines are labeled on there. Now, in this kind of a problem, I have x times y now. So that's going to be a little bit of a difficult point to get by, because I can't take x, y and plug it in here. I could solve for one of them here, plug it in up there, or I could solve up here and plug it in down here. It doesn't matter which way we do this. So pick, either solve in the first one and plug it into the second, or solve for one of these in the second and plug it into the first. It does not matter. Solve in the second. Why, Jay? I agree with you. I think the second one would be easier. Now, for the sake of something I want to show you, I'm going to solve in the first one. There's a reason. I agree with Jason here. I would solve this. I would move the y over or move the 2x over and then divide by negative 1. I would solve it here and plug it in up here. That's what I would normally do. But I want to show you something that might come up later on in math that will help you. So for that reason alone, I'm solving in the first one. Okay? So in the first one, I'm going to solve for y in the first one. And there is a reason I did this. It's not just for fun. So solve this for y. Divide by x, divide by x. This becomes y equals 4 over x. Again, divide by x on both sides. The x's cancel. You get y equals 4 over x. Anybody remember what that's called? Think back to one of our concepts when you have y equals a over x.
Indirect.
What is it? Indirect variation. Very good, sir. Good memory. Again, remember, if it's like y equals 4x, that's direct variation. This is an example of indirect variation. Indirect variation, remember, look like this. It dropped off. We never showed this portion over here, but it does exist over here. So this was our example of indirect variation. This curve to the hyperbola. Well, it's got another half. It's over here. Now, here's the reason I wanted to do it this way, why I wanted to solve this way. Plug this in for y now. Plug it in there for y. So you get 2x minus 4 over x equals -4. Again, I agree with Jason. If you plug it in the other way, it might be a little simpler. But I want to show you a little trick here that most people don't know. At this point in the problem, a lot of people get confused on what to do here. Because it does look confusing. It doesn't look like anything we've seen before. There's a simple way to remedy this. What is the denominator in one of them? X. 1x, or just x. There's a 1 here, yeah, sorry, and there's a 1 here also, yeah. Now, the denominator is what's bothering me. So, Derek, what can I do with it? Derek? Multiply the two x's. Where? Okay, yeah, I understand what you're saying, but you're not saying it correctly. Let's ask Juliet to help you.
Multiply by the x underneath the 4 both sides, so that we kind of cancel out on that side.
So, can you say that in one complete sentence?
Multiply the x underneath the 4x on both sides.
Okay, so multiply the whole equation by x.
Yeah.
Okay, that's what I wanted to hear. But you're right, I understand what you're saying. Juliet is saying this. You don't want that x there. You do not want that x in the bottom. That's what's throwing us off. So if we go like this, if we multiply this side by x, and we multiply this side by x, this is just a trick. And what's what will happen? Watch. Distribute this x to both of these. God bless you. This becomes 2x squared. Again, x times 2x is 2x squared. What happens here when I do x times 4 over x? It just becomes what?
4.
Good. And this becomes -4x. And now what do you have?
Oh,
You have a quadratic. Move the 4x over, guys. Take a look. Move the 4x over. And we've got a quadratic. I did this for this reason, again, because if you see this on something like an SAT, this is no different than any other problem. If you got a denominator with a variable and you want to get rid of it, just multiply the whole equation by that denominator. It does work. Okay? Again, because this x was down here, because of this x right here, we multiplied the whole thing by x. Now, solving this quadratic formula, we get -2.73 and very good, 0.73. Again, run this into your quadratic formula or quadratic program. Yes?
We got 2x squared minus 4 equals -4x. I mean 4x, right?
-4x.
And then you got 2x squared plus 4x.
Okay? I just moved the 4x over. If you take these two values and plug them in, which one would you plug them in, guys? It really doesn't matter, actually. I don't think. I mean, I would probably plug it in the first one, actually. Aren't we looking for y, guys? Didn't we just get x right now? Isn't this what y is equal to right here? So, take 2.73 negative, plug it in right here. I trust you. Listen, guys, please stop talking for a minute. We're not done. Take -2.73, plug it in there, get a y. Take positive 0.73, plug it in there, get a y. Don't go back to your original equations. You solve for y. This is the definition of y right here. So plug them in. I see your hand, Trayvon. Give me 1 second.
It's okay.
-1.5 and 5.5.
And 5.5. Very good. Now, just to see as a graph, and the answers were, this was our 0.73, 5.48, that was that one. And this one here was -2.73, -1.47. Before you guys go, take your homework worksheet, please.
I have the